Okay, so turn to page 3 of your notes. Today we're going to learn about limiting reactant problems. So they're very similar to regular old stoichiometry, except that you have to do stoichiometry twice for each of these problems. So they're longer, but it's the same process. So typically, so I have a little example here. So if you have 8 car bodies and you have 48 tires, okay, you can put 4 tires per car body. So how many tires would you need to make all the car bodies, okay? So you'd say, well, okay, so that's just 8 times 4, right? So you'd need 32 tires. But if you have 48 tires, then you have more than what you need. So you can make 8 complete cars, plus you'd have 16 extra tires left over. So we would say that there is one thing that is limiting how many cars you can have. So if I think of these as reactants and I think of this as products, okay, then this is what you call the limiting reactant. And this is what I call the excess reactant or the reactant in excess. Either one is the same thing. Okay, so a limiting reactant is the reactant that's used up first and therefore limits the production of the product once it's used up. No more product can be formed. You can't make any more once you use it up. The excess reactant is the one that you have left over. So you have excess. You have too much, more than what you need. Okay? So we're going to do a quick example here. Okay, so it says, what is the theoretical yield of aluminum oxide produced when 12.0 grams of aluminum metal is burned with 13.0 grams of oxygen gas? Okay, so I've got aluminum plus oxygen gas, and it's going to produce aluminum oxide. It tells me that in the problem. Okay, so then you just have to balance it. So in this case, I have 12.0 grams of aluminum and 13.0 grams of oxygen. So I have 2 things to start with for my reactants, and I want to know how much in mass, in terms of mass. Theoretical yield, this means grams, okay? So I'm looking for theoretical yield in grams of my product. So I have to do this twice. I have to do one where I go from grams of aluminum to grams of aluminum oxide, and I have to do one where I go from grams of oxygen to grams of aluminum oxide. So I would say I would start with my aluminum first. So I have 12.0 grams of aluminum, and for every 26.98 grams of aluminum, that's 1 mole of aluminum. And for every 4 moles of aluminum, I make 2 moles of aluminum oxide. And then for every 1 mole of aluminum oxide, I need to find the molar mass, so I can kind of stop for a second and do that. Okay. So 2 times 26.98 plus 3 times 16, 101.96. I don't know if you can see that. There you go. 101.96 grams of aluminum oxide. Okay, so we have to put that in the calculator. Okay, so I have 12.0 times 2 times 101.96 divided by everything on the bottom, 26.98. Also on the bottom, so divided by 4. Okay, and I have 3 sig figs at the beginning, so I need 3 sig figs at the end, so that's 22.7. Okay, don't box it though, because you have to find the other one now. So then for oxygen, okay, so I've got 13.0 grams of oxygen. So I'm going to start with 13.0 grams of O2. And then for every 1 mole of O2, I have 32 grams of O2. And for every 3 moles of O2, I have 2 moles of aluminum oxide. And for every 1 mole of aluminum oxide, same molar mass, I don't have to calculate it again, 101.96 grams of aluminum oxide. So then I just have to find that in my calculator. So 13.0 times 2 times 101.96 divided by 32 divided by 2. And again, 3 sig figs, so that'd be 41.4 grams of aluminum oxide. So what I'm saying when I calculate both of these is if I use up all of the aluminum, I can make a maximum amount of 22.7 grams of aluminum oxide. If I use up all of the oxygen, I can make 41.4 grams of aluminum oxide. This is assuming that the other reactant is in excess if you're going to make this. So once I make 22.7 grams of aluminum oxide, I've used up all of one reactant. So I can't make any more at all. So this is my answer. So when you do this, really the lower of the two, once you have made the lesser of the amounts, you've used up all of one reactant and you can't use any more. Which means in this case, aluminum is the limiting reactant and oxygen is my excess reactant. So in addition to answering for the theoretical yield of product, I have to identify what was limiting and what was in excess. Okay? I wouldn't just say limiting reactant over the top of 22.7 grams aluminum oxide because aluminum oxide is not a reactant. Please don't ever label the end product as a reactant. That means you don't know your vocabulary. You haven't been listening in chemistry this entire time. This is not the limiting reactant. This is the amount that could be produced if I use up the limiting reactant. That's all that this is. Okay? And that's how you do limiting reactant problems. Now, I also need for you to set up your lab notebook for the airbag lab that you're going to do next class. So get your lab notebooks and turn to a fresh page and let's get started. Okay, so you want to turn to, if you're not at this place with me, if you're still getting lab notebooks, pause the video and then get your lab notebook and then start playing again. But this is where I am. So you have your homework packet. This is at the end of the homework packet is this thing. It's called Don't Make It Pop, but that's it's like a directive. I don't want you to pop the bag. Instead, I want you to fill it with a product, the maximum amount that you could possibly produce. So, all right, so you have some background information here and you can read about that, but what do you need for your lab notebook? Obviously you need the date and you need your lab partners. You need the title. I don't really care if you have the background information, but you should read it. You definitely need the purpose. Okay, and so it says the purpose is you're going to use stoichiometry and reaction prediction between hydrochloric acid and sodium bicarbonate to inflate a bag with gas evolved from a chemical reaction without underinflation or overinflation. Okay, so you're going to be using 1.00 molar hydrochloric acid, and you're also going to be using sodium bicarbonate. So those are your two chemicals that you're going to use. Okay, you're going to use the rest of this stuff too, but those are the big deal. And you're also going to get a plastic baggie. Now, I do want you, because we are using a very caustic chemical, you are going to have a hazard section. So you're going to have to write down these hazards verbatim, okay, in your lab notebook. You must wear goggles through the entire lab. There will be a calculation portion at the beginning of the lab. I don't really care if you have goggles on for that. But the moment anybody in the room is done with calculations, you will put on goggles because you will start working with chemicals. Hydrochloric acid is very corrosive to body tissues. So if you get any on you, and although 1 molar, it seems like, oh, that's 1. 1 seems like a low number. It's not that bad. So if I get it on me, it won't be that bad. 1 molar is pretty strong acid. So if you get it on you, it will burn, it will hurt, and you'll have to wash it with copious amounts of water for 15 minutes. Should you get it in your eyes, you will have to stand in the eye wash and wash your eyes with copious amounts of water for 15 minutes while somebody goes to get the nurse and possibly call you an ambulance. Okay? Do not play around in the lab. Okay? And when you're done, just in case some may have splashed on you or on your wrist or something by accident, you need to wash your hands at the end of the lab. Be very careful, okay? All right, so we definitely need to have, right, date and who your lab partner is, the title, the purpose, the hazards, verbatim, right, the exact words for your hazards. All right, and then you are going to have to write your procedure this time. Okay, you're going to have to state your hypothesis in an if-then statement. And then with your partner, you're going to design a laboratory procedure. So really what you're doing, and you're going to have all these calculations. So what you're going to do, you're actually doing this part. You're not going to write down 1, 2, 3, 4. You're going to write down number 2. You're going to design a laboratory procedure and complete all the calculations and show your plan to the teacher before you test it. You're going to carry out your experiment only after I have approved your numbers. So you must have approval before you are allowed to carry out your experiment. Then if it's not right, if something went very, very wrong, okay, then you may revise your experiment, including your math, and repeat and show me the filled bag, okay? Otherwise, you might get a bad grade. You don't want a bad grade. All right, and then you will have the analysis questions where you must write the question and the answer, both, okay? Now, this procedure portion, this is probably going to take you a half to a full page to write. So you want to leave plenty of space for your procedure, and then you're going to have your analysis questions where you're going to write the question and then the answers, okay? And that's it. That's what you're doing. For the rest of class today, you can get your lab notebook set up. You can also complete page 6 and 7 of your homework while you're in class today. That way you don't have homework over the weekend. It is, I think it's only 7 questions. Yeah, but they're like double stoichiometry problems because it is limiting reactant. Okay? Be sure to write the balanced equation to begin with. If you don't write the balanced equation, you can't do stoichiometry. We will check your homework in depth when I come back because I'm not in class today. So we will check that in depth for my Green Day students. So have that ready to go for me to check. For now, you have the answers, and I will put the answers to this behind the LCD projector screen. So if you would like those, you are welcome to take a picture. Okay?